subtopic number 2, which is on molecular kinetic energy and internal energy. So in this subtopic, you have to be able to explain and use translational kinetic energy of a molecule, define degrees of freedom, identify the number of degrees of freedom for monoatomic, diatomic, and polyatomic gas molecules, state the principle of equipartition of energy, discuss internal energy, solve problems related to internal energy. Okay, so let's look onto the average translational kinetic energy of a molecule. So we are going to use this equation here. So based on this equation, it can also be written as something like this. Okay, so they separate there. So P is equal to here and kenapa dua ni? I think it should be 1, but why did I put it as... No, what's happening? Tiada 2/3 ni sepatutnya. Sebab kita sudah extract 1/3 tu. Tapi, let me double check lah. Mungkin, don't know if I'm wrong or this thing is wrong. This shouldn't exist here, I think. Kenapa ada 2/3? Oh, okay. It's correct. It's just that I haven't keluar this one. Okay, so it should be 1/2. Sebab this 1/2 mvr square ni is the average translational kinetic energy. Okay, so this part here is KTR, average translational kinetic energy. Okay, that's why the 2/3 NV di depan, sebab diambil half untuk pergi di sini. Okay, so based on this equation here, it indicates that the pressure of the gas is proportional to the number of molecules per unit volume. So sekarang ni, P is directly proportional to the number of molecules per unit volume. Okay, also to the translational kinetic energy. Okay, so since PV is also equal to NKT, P can be written as NKT over V. So if we compare this two here, we will then get an equation like this. Okay, so what is this? This one is the average translational kinetic energy untuk gas molecule. Okay, so ini untuk a molecule, untuk the gas punya molecule. So this one is the whole gas, the average translational kinetic energy untuk the gas. Okay, does it make sense? Tapi yeah, it is. I don't know if it makes sense. Okay, tapi yang ini adalah untuk of a gas molecule lah. So this is for a gas molecule, this equation here. Right? And then since the Boltzmann constant is equal to molar gas over the Avogadro's constant, we can also write it down as this equation here. Alright? So this result tells us that temperature is a direct measure of the average translational molecular kinetic energy. Okay, so at a given temperature, all of the ideal gas molecules should have the same average translational kinetic energy. Okay, so ini based on this equation lah apa yang dorang boleh conclude. So the total translational kinetic energy untuk N molecules is simply N times the average kinetic energy of the molecule. So kita boleh just darab dengan N untuk dapat berapa banyak translational kinetic energy untuk specific number of molecules tu. Okay, so that's why dia darab je dengan N. So bila kita darab dengan N, kita akan dapat this equation here. So this is the total kinetic energy untuk N molecules. N ni apa? Number of molecules lah. Ini untuk specific number of molecules. Yang ini untuk the whole gas molecule. Okay, so all of this is for the whole gas molecule. except for E tadi, the total kinetic energy itulah. Total translational kinetic energy. Okay, so the equation that is important here is basically all of it. Tapi, di kamu confused. So it's this, and yep, that's basically it. Just have to remember. This one pun sama juga. This is actually this part here. This part is just this one. Okay, all right. So that is the equation part. Next, we have degrees of freedom. So degrees of freedom is an independent mode of motion ataupun independent way in which a gas molecule acquires ataupun store energy. So kita ada 3 types of orientation mode in the molecules. So they can move linearly ataupun translational, rotational, and vibrational. So vibrational ni boleh present only at very high temperature lah. Sebab macam apa tu cacing kepanasan. Dia panas baru dia gitu-gitu. Yalah, baru dia vibrate. So the number of degrees of freedom depends on whether the molecule is mono, di ataupun polyatomic lah. Okay, so this is when the translational motion at the center of mass, then this is rotational motion, this is vibrational motion. Okay, so this is a table that's just telling you about how many number of degrees of freedom is present for mono, di, and polyatomic gas lah. Okay, so this is the formula untuk monoatomic gas. This is okay, so this is the what do I say, the number of, that is the principle of equipartition of energy ataupun dorang punya average molecular kinetic energy lah. So dorang punya average molecular kinetic energy ni, it depends on the degrees of freedom. So untuk monoatomic gas, dia boleh move di X, Y, and Z sahaja. So dia ada a total of 3 degrees of freedom je. Dia boleh bergerak dengan free di X, Y, and Z. Sama juga dengan diatomic gas, X, Y, and Z. Tapi dia boleh rotate around its axis and then rotate macam tu juga. So dia ada 5. So untuk polyatomic gas pula, dia akan banyak lagi motion ataupun degrees of freedom. So dia ada 6 lah in total. So this degrees of freedoms relate to the principle of equipartition energy lah. So the principle of equipartition of energy ni, they state that the average kinetic energy stored in each degree of freedom is half kT. So 1 degree of freedom equal to half kT. So kalau dia ada 6 degrees of freedom, darab dengan 6. So dapat 6/2 kT. So ini adalah dia punya average mean kinetic energy stored in 6 degrees of freedom. Okay, so in general, untuk gas with F degrees of freedom, the average kinetic energy per molecule can be expressed as shown here. Okay, so half F kT. F tu apa? Number of degrees of freedom lah. Kalau dia ada 5, kita letaklah 5. So dapat 5/2 kT. Macam tu lah. So kita apply the principle of equipartition of energy ni to the average molecular kinetic energy, kita akan dapat this equation here. Okay, the one that I've written on this table here. Alright, so this one is important lah. This is your average kinetic energy per molecule untuk relate dia dengan degrees of freedom. Okay. Next, we have internal energy of gas. So that is U. So this is the basic internal energy is the summation of the kinetic energy and the potential energy of all molecules of gas. Okay, the potential energy is associated with the forces between the gas molecules. Tapi if you remember the assumption of ideal gas, kinetic theory of gases, in ideal gas too, the intermolecular forces are assumed to be negligible. So bila dia ada forces between these atoms ataupun molecules, the potential energy of the molecules can be neglected. So internal energy ni sekarang ni adalah just the sum of the average kinetic energy of its molecule. So tiada sudah potential energy. Dia adalah untuk average kinetic energy of the molecule saja. So if there are n molecules in the ideal gas, the internal energy is simply n multiply with the average kinetic energy of a molecule. Okay, so sekarang tadi tu kita tahu the average kinetic energy is half FKT. Tapi sekarang ni kita mau internal energy. So dari internal energy ni kita akan just darab dengan number of molecules, which is n. So kita darab dengan n supaya kita dapat kenapa John? Supaya kita dapat dia punya internal energy of the gas. Okay, so it's the summation of the average kinetic energy of its molecules. Alright, so ini adalah formula untuk U. So wait, it can be this one, also this one, sebab kita boleh relate the number of molecules dengan the Boltzmann constant ni. Okay, so dapatlah equation yang ini. Okay, so apa maksud each of this term? Kamu boleh refer to here. So this result of the equation implies that the internal energy depends only on the temperature. Okay, so it depends on the temperature saja. So kalau there is a changes in the temperature, increase ka internal energy will also increase. Okay, and vice versa lah. Okay, itu je lah. So apa yang kamu perlu ingat? As temperature changes, the internal energy of gas will also change. Alright, so that is on the theory part. Let's move on to the example. Okay, so a vessel contains hydrogen gas of 2.2 times 10 to the power of 18 molecules. So per unit volume. So that is N over V 2.2 times 10 to the power of 18, and the mean square speed is V square is 4.5 kilometer per second. So kilo is 10 to the power of 3 meter per second. Lepas tu temperature dah 50 degrees Celsius. Remember, you have to convert pergi Kelvin. So 50 plus 273.15, kamu akan dapat 323.15 Kelvin. So we have to determine the average translational kinetic energy of a molecule for hydrogen gas. So that is KTR equal to 3 over 2 KT. Kenapa kita guna yang tu? Sebab tadi kita sudah cakap this is for the molecule, gas molecule. So kita guna formula yang inilah, 3 over 2 KT. So kamu just substitute lah. K sudah K is a constant, you have to remember that. And T sudah ada, so kamu akan dapat 6.69 times 10 to the power of negative 21 joule. Right? Next, the pressure of hydrogen gas. So the pressure of hydrogen gas is so we have two pressure punya equation. We have P equal to 1 over 3 1 over 3 rho m VRMS square ka? Where is it? Okay, so we have this and we have this here. Okay, so based on this we can actually use ini ba ni kita boleh guna. Okay, so we can use this equation. Tapi let me just write it down supaya I can compare these two equations. So we have rho VRMS square, then we have P equal to 1 over 3 NM VRMS square. Should I just, gitulah, over V. Okay, so there are the over V di situ. So basically, if we see this, it is much easier to use this equation sebab rho ni just equal to NM over V juga. Okay, so if we use this equation here, we can write it as P equal to 1 over 3 N over V, which is already given there, which is M VRMS square. Okay, so kejap, dia bagi mean square speed. That's not root mean square speed, that's just mean square speed. So if it's just mean square speed, mean square speed. Oh, okay. Sorry. So, betul lah. Kejap. So, basically, VRMS square is equal to... Ayan, nanti kamu confuse lah. Tapi apa. So, VRMS square, kita boleh kasi betul. Now. Okay, so apa yang kamu perlu ingat? VRMS is equal to V square. Okay, this is root mean square speed. Tapi kalau VRMS square, it is equal to V square. Okay. So that's why the one is written here, kita boleh just substitute dalam ni. Okay. Kalau kamu confused saja, tapi I don't really think you'll get confused lah. Okay, tapi sekarang ni kita tidak value of mass of the gas. So, kita perlu cari M, which is gonna be equal to M over Avogadro's constant. So, this one is from M over capital M N over NA. Okay? Okay. So, kita akan dapat M to be equal to M over NA. Okay, dia cakap yalah, betul lah, macam tu je. Tapi M over N. N is I would say N equal to 1 because, but the problem is for a molecule of hydrogen gas, okay, for a molecule, okay, so basically this is my answer lah. So since dia minta for a molecule, kita akan letak N should be equal to 1. Okay, so that's why kita boleh conclude macam ni sekarang ni. That's why the N ni hilang, dia jadi macam ni saja. Okay, because N is equal to 1. Okay, so dapatlah molar mass over Avogadro's constant. So kalau kamu substitute, this will be 2.2 times 10 to the power of 18. M is, what is this? Hydrogen, 2 grams. So 0.0, 1, 2, 3. 1, 2, 3. Okay, betul. Over 6.02, 10, 23. This is 4.5, 10 to the power of 3. Okay, yeah. So, kamu akan dapat the pressure of the hydrogen gas to be equal to 1.1 times 10 to the power of negative 5 Pascal. Okay. Yeah, so that is the solution for example number 3. Example number 4 pula. We have a vessel that contains an ideal polyatomic gas. So sekarang ni polyatomic gas at temperature of 30 degrees Celsius. So the degrees of freedom for polyatomic gas is equal to 6. And then we have temperature 30 plus 273.15. That is gonna be equal to 303.15 Kelvin. And then the total translational kinetic energy of the gas molecule is 6 times 10 to the power of negative 6 joule. The mass of the gas is then doubled. So doubled. And then the total translational kinetic energy becomes 13 times 10 negative 6 joule. So we have to determine the new temperature of the gas. Okay, so we know that the total translational kinetic energy punya equation is 3 over 2 times N ke T ataupun 3 over 2 NR T. Okay, so it's either one lah, mau guna mana satu pun boleh. Tapi sekarang ni since kita we know that okay, wait, I'm gonna use the first one je lah. Okay, so sekarang ni kita akan cari N dulu because we have to relate dia dengan the mass of the gas. So we know that the number of molecules is gonna be equal to M over the molar mass times the Avogadro's constant. So this is from M over M N over capital NA. Okay, and then we know that K is equal to R over Avogadro's constant. So kita punya equation ni akan jadi 3 over 2 NA dito keluar dulu. K is R over NA. So kita punya NA ni boleh cancel. So kita akan dapat 3 over 2 M over M R T. Okay, so this is actually just an RT. Kan? See? That's why you have to remember formula mana yang sesuai. So kalau kamu ingat terus mau guna yang ini, kamu boleh just change N ni pergi mass of the gas over the molar mass of the gas. Okay? So dari sini kamu boleh just do for the first temperature and the second temperature lah. Okay? So for this one it will be 3 over 2 M over molar mass RT. So this is your first equation. And then we have the second equation when the mass is doubled. So when the mass is doubled, it will become 2m RT prime. Okay? So kita boleh cancel apa yang boleh cancel. So basically just you can equate ataupun bahagi lah. So I would bahagi. So this will be 2m over m RT over 3 over 2. So cancel lah apa yang boleh cancel. Kita cancel 3 over 2, 3 over 2, R boleh cancel. M ni pun boleh cancel. So kamu akan left with you will then be left with you will left with E prime over E equal to 2m over M ni pun boleh cancel, lupa pula. So kamu akan tinggal dengan 2 dengan T je lah, the number and T je. So this is gonna be 2T over T. Okay, so dari sini you will then get T is equal to 328 Kelvin. Okay, so if there is any confusion on the maths part of this question, I guess you have to meet me lah so that I can explain to you better ataupun try tanya kawan kamu. Tapi this is basically how you would solve this question lah. And then next we have to determine the internal energy of the gas. So the internal energy of the gas, kenapa mau cari internal energy of the gas? Oh, okay. So the internal energy of the gas is just U equal to, what's the formula again? Half NFRT. Is it? Yeah. Okay, so N tadi kita sudah, oh, but we don't have M. Yeah, that question is actually not valid because I added myself without, oh, but it's okay. So assuming N is equal, ada kah dia bagi M di sini, molar mass? Tiada juga. Okay, so I can't do that. Okay, never mind. We'll just cancel the question. So I'm not gonna add it into your notes. Okay, so this is for example number 4 and basically the whole second subtopic lah.